Let's start out by discussing the goals in our case study. We'll be designing an object-oriented expression tree processing app using patterns and frameworks. Expression trees are used to remove ambiguity in arithmetic expressions. And you've undoubtedly run across these whenever you use a calculator or some other type of tool that involves processing input expressions. We're going to be using this particular example to compare and contrast algorithmic decomposition and object-oriented design and programming, two different ways of trying to solve the same problem. Even though object orientation has been around for quite a long time, it's surprising the extent to which algorithmic decomposition is still used in practice. So we'll cover that in order to see what alternatives may be out there that you may actually run across in the work that you're doing. We'll also use this particular case study in order to demonstrate scope, commonality, and variability analysis, which is a method for trying to achieve systematic reuse of software by looking for things that are stable or common and making sure that they have a fixed interface, looking for things that vary, making sure that things that vary also have a stable interface, and then finding ways that you can combine the two together in order to be able to build software that can be reapplied in multiple use contexts. We'll be applying scope, commonality, and variability analysis through all of the different patterns we'll look at in the context of our case study. We'll also illustrate how pattern-oriented, object-oriented frameworks can be implemented in Java. And we'll illustrate the way in which the Java programming language and its class libraries can be combined in order to realize different patterns, either by convention, the way you write the code, or in some cases, actually have these patterns baked into programming language features, such as the Java for each loop.